so let's sum up topic 2, kinematics, 2D motion. This last video is going to be on projectiles launched at an angle. The equations we already went through in the previous slides. Let me look back here real quick. These are the equations that you want to look at now, the ones that you have to embed cosine theta or sine theta in with your VI based on an initial horizontal velocity of, that would be the first one, or an initial vertical velocity of the second, third, and fourth based on what other givens and unknown you have in the problem. So let's try this problem out together. Reading through it says a robber is running from a police officer across the rooftop of a building. He knows that there's a 4.0 meter gap between this rooftop and that of the next building, so he leaps with a velocity of 5.0 meters per second at an angle of 15 degrees with respect to the flat rooftop on the next building. But if the next building's rooftop is 2.5 meters shorter than the one he's currently on, that should say on, sorry, will he land on the next rooftop or splat? Okay, so going into this problem, we know that we have an x of 4.0 meters. We know that we have and I'm going to just put this in parentheses right now, be more specific, a y max of a negative 2.5 meters, because that second rooftop, he's going to jump from one rooftop. There's a 4-foot gap between these two rooftops, and there is a 2.5 meter difference between the heights of them. So that's kind of the idea that I want you to have in your head right now with these buildings or this problem. Okay, moving right along. So something else that you know is you have an initial velocity in the y direction of 5.0 meters per second, and you know that you have acceleration due to gravity in which you are falling down. Needless to say, you're jumping from the top of one rooftop to the top of one that's lower than. So therefore, you want to actually solve for your delta y in meters of, okay, so how far does this person fall, you know, once they leap off at this initial vertical velocity at this angle? Do they fall down way too much, or do they fall less than 2.5 meters? So the ultimate answer is this robber is successful in running across this 4.0 meter gap if they have a vertical distance, displacement delta y, of that less than 2.5 meters. So technically we're solving for a delta y, right? So ultimately we want to use a delta y equation, which means we need to start with a delta x equation, and as you know, there is only one delta x equation, but big difference on this problem than the previous one is, I forgot to write it in as a given, you have a theta of 15 degrees. Okay, so with that in mind, you want to start with delta x equals VIx cosine theta delta t. You want to solve for delta t. In this equation, how did I know that? I'm going to erase this, but right now I'm going to just put down, because you want to use a delta y equation that does not have VF in it at all. And the one that does not have VF at all is VI sine theta delta t plus 1/2 g delta t squared. Okay, rearrange this. We have delta x over VIx times cosine theta equals delta t. Okay, so plugging into that, that gives us 4.0 divided by 5.0. So let's go over here and fix this real quick. You have an initial velocity of, and we're going to leave it at that. You have an initial velocity of 5.0 meters per second. Nice error to catch there, guys. Okay, so your initial velocity is 5.0, and you have a cosine of 15 degrees. So in your calculators, 4.0 divided by start it, 5, end it, start it, cosine 15, end it. Talking about your parentheses there. Enter. Should give you a calculator answer of 0.83 approximately. So therefore, your delta t, looking at your sig figs, is 0.83 seconds. It's not a final answer, so do not box it. Okay, I am going to extend the page on this one, so hopefully you can still see that pretty clear. So then that gives you your VI of 5.0 times the sine of 15 times 0.83 plus 1/2 times a negative 9.81 times 0.83 squared. I would chunk it. Get your 5 sine 1583 answer. Get your 0.5 9.81 83 squared answer. Doing so, this first half should give you a 1.1. Then the second half is going to give you a negative 3.4. So therefore, that's going to give you a negative 2.3, which means that this person falls down 2.3 meters. Therefore, yes, the robber is successful in making it onto the rooftop of the next building. Okay, last thing I want to put in here is that you are to use physicsclassroom.com big time with this guy. I really think they have stellar examples. They have awesome sample problems. They actually have the math calculated out in them. They even have some really cool like bets, which are simulations that you can run. So I made a little disclaimer as well to check out the animations that are on this slide. I think, or this website. I think it does a really good job of showing this to you guys. Now that sums up your topic 2, kinematics. 1D motion, 2D motion, all that stuff. So we're officially now done with kinematics. Please work on your projectiles worksheet and your relative velocity worksheet.